So this is the first class of vital statistics. Uh, Vital statistics. The term vital statistics signifies the data or the techniques used in the analysis of data relating to the vital events occurring in a given community. Vital statistics are conventionally numerical records of marriages, birth, sickness, migration, divorce, and deaths of which the health and growth of a community may be studied. What is demography? Demography, demos plus graphy is equal to demography. Demos means life, and graphy means this means life, and graphy means descriptions. The study where descriptions of human life is discussed in detail can be considered as demography. Demography is concerned with the growth, development, and movement of human populations as aggregates. Its raw material ranges from the statistics of heights and weights or the blood pressure in a man, or to the distributions of the rents the pay for their housing accommodations, or to the classes of educations they given their children. Now the next question is, what is vital events? Vital events. What is vital events? Vital events are the events related to human life, such as birth, death, mi- migration, marriage, divorce, separation, adoptions, sickness, population growth, etc. Now the next point, there are four important sources from which the raw data of vital statistics are generally obtained one census. A census represents a comprehensive profile of a country's population. Census operations are conducted in almost all countries at intervals of 10 years. In a census, the enumerations of every individuals of in all the enumeration of every individuals of all habitational areas is carried out at a specific time. In a census, besides counting the number of persons living in a specific regions, information regarding their age, sex, marital status, education's level, occupations, region, familiar characteristics of individuals, etc. are also compiled. But information available for the census year only, that is the informations, the because we collect data each 10 years interval, so and this information is available for the census year only. Hence, census data fails to produce vital statistics for intercensal interval. Suppose if you if the census occurred at the year 2020, then after 20 years it occurred at 2020, 2010 first, then 2020. If you want the data in between that, suppose 2015, in that case this census data fails to produce vital statistics for intercensal years. Moreover, the data obtained in respective of births and deaths are not complete even for the census year. Hence, the census enumerations fails to produce data suitable for vital statistics. Next point, first point is census. Second point, registration data. In a community, there is a system of registering the occurrence of several vital events to the proper authorities under legal requirements, especially for the vital events like birth, next, for example, death, marriage, like marriage registration, death certificate, birth certificate, marriage registration, the events is marriage, divorce, etc. So, from vital statistics registers, we have data regarding number of these vital events, that is birth, death, marriage, divorce. In a case of death, when a children is born, the information with regard to the date of birth, place, name of the father, sex of the newborn, nationality, religion, process, processions of the parents has to be profession of the parents has to be reported to the appropriate authority in the area. That is, in case of birth, you observe that we generally consider the place. Next point is name of father, sex of newborn, that is male or female, then nationality, age of the mother, religion, professions of the parents has to be considered. And in case of death, the information in respect of date of death, name of the disease, his or her father's or husband name, place of death, age at the time of death, sex, male or female, marital status, married, unmarried, divorce, etc., religion, cause of death has to be considered or registered by appropriate authorities, because the disposal of body requires a death certificate from the authority. So there are three kind of birth. One is live birth. Live birth means the complete expulsion or extractions from its mother of a product of conceptions, irrespective of the duration of pregnancy, which after such separation breathes or shows some other sign of life. Each product of such birth is considered as a live born. Next, stillbirth. Stillbirth is mean death of a product of conceptions that has completed 28 weeks of gestation period to separations from its mother, the death being indicated by the fact that after separation the fetus does not show any sign of life. Next is fetal death, means death of fetus before separations from mother may thus be either a stillbirth or a miscarriage or abortions, according as it occurs after or before completions of 28 week 28 week 28 weeks of gestations. The death is indicated by the fact that after such separation the fetus does not breathe or show any other sign of life. Such a beating of sign of life means such as beating of heart or pulsations of the pulsation, etc. These are the sign of life. Next point, third point, that is hospital record. Every hospital has every hospital as well as nursing home or health center or any public health program maintain records for each patient about such particular as the age, sex, mother name or father name or husband name, etc. of the patient, along with the nature of illness, the type of treatment applied to the patient, and also the outcome. So, information regarding cases of disease or group of disease and also the cases of birth and death that occurs in hospital or nursing home can be obtained from these hospital records. Next and last point, that is ad hoc surveys. In countries with defective registration systems, occasionally surveys are conducted to collect data on vital events. In our country, National Sample Survey Organization, in short NSSO, occasionally conducts special surveys to collect raw data on some particular vital events of some specified characters. These are the four points, four methods of collecting raw data of vital statistics, that is census, registration data, hospital record, and ad hoc survey. Principles in census. The principles are: the nature of population should be the nature of population should be specified to census should be taken in a single day at least with a at least within a fixed period. Census should be taken census should be taken every 10 years at least. And fourth principle is the census should necessarily include those information necessarily include these informations, namely name, age, sex, relationship with the head of the family. Suppose in a family head is a husband, then the relationship with this person, every person, suppose there are three person, one boy whose father is a head of the family, the relationship is a son, then a woman, a maybe is a she is a daughter or wife, so those relationships are recorded. Data of birth, how many births are there, place of birth, every individuals in a family, we consider place of birth of individuals, mother tongue, marital status, knowledge of language, permanent residence, nationality, physical disability, etc. There are there are four stages to conduct this survey. That is, one is planning stage, two enumerations, three procedure or compilation stage, and last is analysis and reporting stage. There are two procedure of census, that is de facto procedures. In this case, the persons will be counted at that place in that time of taking census, and next is, that is, de jure procedures. In this case, the person will be counted at his permanent residence. The type of the method should be critically examined. Now, next point is different errors in census data. The errors that are found in census are classified under two heads: errors in census data. These are classified into two parts, that is errors of coverage to errors in response. Errors of coverage during a census, some individual or even some families may be left out of the count, while some others may be erroneously included or included more than once. So these errors of coverage in census data may be taken care of by a sample check. This sample gives an estimate of proportions of persons left out or included more than once. On the basis of these estimates, the enumerated figure may be adjusted. Next point is errors in response. The most serious errors under this category are found in the information gathered on the age. This needs special attention as the age compositions of the population is vital for most demographic studies. Generally, in population statistics, age are considered to be completed on last birthday. For example, a man of age 31 years 3 months is said to be of 31 years. Similarly, a man of age 31 years 9 months is said to be again 31 years. Now, an error occur in age. Figures may be census enumerators do not follow the meaning of age 0 last birthday. As a result of this, many children of exact age below they get recorded as of age 1 LBD, that is last birthday, while really they are of age 0 LBD. That means, suppose a children of age 6 months, they consider 1 LBD, which is not correct. It should be a 0 LBD. And So, I already mentioned that as a result, this makes children of exact age below they gets recorded of age 1 LBD, while really they are the age of 0 LBD. So it has been found that in most census, children in the first few years of life are undernumerated. Hence, the population figure of age 0 LBD may be too low and that of age 1 LBD may be too high. Too low means suppose 1 month, but we consider 1 LBD, that means more than 1 years. So this difference is too high. Next, people have a natural tendency to state their ages in round figures, that is 0 and 5 or multiple of 5 or even digits. This leads to considerable heaping at age ending with 0 and 5 and some heaping at ages that ended in even digits. This heaping occurs at the cost of other ages which show a deficiency of people, this being particularly noticeable at the age like 13, which number tends to be avoided especially in a western country. This type of errors may be called careless error. This type of errors called careless error. Next point, since people enjoy certain legal and social advantages or reaching majority, that is age 18, young people often tends to report their ages as 18 before actually reaching that age. Again, young people, especially women, have a tendency to understate their age after attaining majority. Old people, on the other hand, exaggerated their age to avail the benefits of senior citizens. This type of errors may be called willful errors. First, careless error, and this error is willful errors. Next, methods of guiding against the adjusting error in age returns of census data. The enumerators should be given a better type of training explaining the significance of all the terms included in the census schedule. Enumerators may put indirect questions to have an idea about the correct age figures, that is to inquire about the date of birth of a person in addition to his and her age. This will be appropriate when the people being enumerated are illiterate. Once the age returns have been received for more or less correct age distributions, one may use, instead of 1 year age group, border age group so that the edges at which the clustering or heaping occurs fall somewhat at the middle of such age groups. Myers method Myers developed a test for picking out the best 5 years grouping. The possible 5-year groupings may be distinguished as 1 to 5, 2 to 6, 3 to 7, 4 to 8, and 5 to 9. If we consider the end digits of the various ages and note that each of the given clusters determines a complementary cluster, example 1 to 5, this 1 to 5 determines 6 to 10. This 1 to 5 determines 6 to 10. 2 to 6 determines 7 to 11, etc. Now if we add the percentages at various individual digits for each 5-year groupings, then each case we should get a sum close to 50% according to Meyer test. That 5-year grouping is to be preferred, for which the sum come closer to 50%. Next, in census, the age of some persons may not be recorded. The cases where age is not available, in this situation the common practice is to distribute the number of persons of this category among all age groups in proportion to the numbers already available against these age groups. Total population size, we denote this by capital N, divided into two parts. Population size where ages are available, we denote this population subpopulation by N1, and population size where ages are not available, and we denote this by N2. Now note that this N equal to N1 plus N2. Now we construct a table whose first column is ages and the entries are 0, 1, 2, 3 up to k. Population where age figures available, and the corresponding frequencies f0, f1, f2, f3, fk. Then this total, that is summation fi 1 to k, this should be n1. Now probability or proportion of people where ages are available, this is f3 by capital N p2, and this sum should be 1. The populations where age figure unavailable, then this should be into p naught. Now the total populations then you see that this is fi, this should be n1 and this is n2, hence this sum gives total populations. Then the number of people in whole population and so on. If case, therefore if you add all these fi, then you get capital N. Errors in registration data, errors of coverage. This means in all countries birth are in all countries births are under registered. When a child dies shortly after birth, the guardians do not care to report it. The positions is somewhat better for deaths since the disposal of a body requires a death certificate. The error of incompleteness may be estimated by sample check. Then errors in response. And this happened in two ways. One, errors in record recording the place in which birth and death occurs. And another way is errors in recording the cause of death. The errors in recording the place in which birth and death occurs, a birth or death occurring in a city hospital may be recorded as an addition or loss to the city population, although actually the mother or the person dying may really belong to the some other area. And in errors in recording the cause of death, this happened. The cause of death may be unknown to the informant. 3. The cause of death may be willfully misstated because the cause of death may have associated with some social stigma. For example, leprosy, tuberculosis, alcoholism, or suicide. And the third point, there may be a number of causes leading to the death of a person, of which one will be the principal cause. However, the principal cause may be wrongly recorded owing to the real difficulty in identifying the true principal cause. Now, rates of vital events. The raw data on vital statistics, which are generally classified according to different characters, say age, sex, occupation, religion, etc., are given in the form of a frequency table, but these frequency values alone will not be enough for a statistical study in population statistics. For example, the statement that in country a 1 lakh people die in a certain years, whereas in a country B 2 lakh people die in same year, which convey no significant implications regarding the death pattern of these two country A and B, unless we know the people's population size of each community. Therefore, it is also necessary at least to know the population size of each community to have an idea as to their relative mortality situations. So, by relating these two, mainly the number of deaths to the population size, we have rate. In this case, in this example, we call it death rate. So we define rate as rate of the vital event, rate of the vital event E. This is equal to number of cases in which vital event E occurs in a given region during a given period divided by total number of exposures to the risks of occurrence of vital event E in a given region during a time period into K. Generally, K is a constant. We generally take this 10 cube or 10 to the power 5 according to every rate is expressed per thousand population. When we multiply 10 cube, then it is a per thousand populations, or when we multiply 10 to the power 5, then it is per lakh populations. According to the definition, a rate will be a proper fractions because the number of cases in which vital events occur in a given region during a given period is less than equal to total number of exposures to the risks of occurrence of vital event E in a given region during a time period. So for case of understanding, the fraction is generally multiplied by this constant, and I already mentioned this constant, either we take 10 to the power 3 or 10,000 or 1,000 or 10 to the power 5, that is 1 lakh. Now every rate relates to a particular vital events, that is birth or death, a given geographical region, for example India or West Bengal. Third, a particular period of time. The second and third point, that is a given geographical region, and third point is a particular period of time, may not be always be expressed, may not always be expressed, but will be understood from the context. The we can define alternatively this rate as if capital N represents the number of occurrence of a certain vital event E, such as birth or death, etc., during a stated interval of time, and capital P represent the size of population within which vital event occurrence took place. That is, this P represents the number of persons exposed to the risks of occurrence of the event E. Then capital N by capital P is regarded as the rate of that vital statistics or vital events. The period of time is usually taken as 1 year. The size capital P of the population is exactly or approximately, capital P is generally exact or approximate. Usually median population size is taken. The rate is a number which lies between 0 to 1. This definition of rate is similar to classical definition of probability. A multiplier called radix is used to round up the decimal. Usually 1000 is taken as a radix, that is which I mentioned in the previous definition of rate, which is denoted by K radix. Usually 1000 is taken as radix so that the rate is per 1000 population, and this is expressed as n by k in n by p into 1000. The number of persons exposed to the risks of a vital event is usually the population of the given area during a given period or some segment of that population. What should be the population of a period, or what is the mean population of a period? As an estimate of population, we may take the population at the beginning or at the end or at the middle of the given time period. However, it is the best to take the average population of the community during the given period. Let PT denote the population at the time t. Assume capital P T to be continuous function of t, then for the time interval t1 to t2, the average population will be this is the length of a time. So concept is, say this is the PT curve. So plot this against t, time t. So this integration represents this area. So the total number of populations in time t1 to t2, and the average time is this divided by the time intervals, that is t2 minus t1. But the population at a fraction of time is rarely available. In its absence, we take midpoint population. If that is again not available, the average of the population at the two ends of the interval is also used. It is to be noted that population can be approximated by a linear function of ft, that is pt equal to a plus bt between t1 and t2, provided t1 and t2 are very closed. that is the interval t1 t2 is a short interval. The justification is, we know the formula, the average population is this. So the average population, if we consider pt is a linear function of t, then we write it as a plus bt dt. Then after integrating, we get this is t1, and it is a plus b t1 plus c2 by 2, and we denote this by p within bracket t1 plus t2 by 2 populations at the midpoint of time interval. Population at the midpoint of time interval. Also, then the average population at the two ends, the average population at the two end equal to pt1 p2 t2 by 2. Then since pt equal to a plus bt, then this is equal to a plus bt1, and this is again a plus bt2 by 2. Then we get a plus b t1 plus t2 by 2. So this is nothing but a simple average of population at the two end point. Hence, in this situation, with these assumptions of linearity in the population, all the approximation are exactly equal to the actual average of the population. This is the justification. Probability interpretations of rate. So we know from frequency definition of probability, for when we take a large trial, that means n tending to infinity, n is a number of trial, then Fna by n, these proportions goes to a fixed value, that is probability of A. This is the definition of frequency definition of probability. That is, observed value Fna and n is a good estimate of Pa. That means I want to say this ratio Fna by n is a good estimate of Pa, where Fna denotes the number of cases in which the event A occurs. The experiment is repeated under same condition, the major conditions, that is, I want to say same condition means in reality is not possible. That means the majority of the conditions remain same. Then we define the rate of events as total number of cases in which vital events occur divided by total number of persons exposed to the risks of occurrence of the event E. And this is denoted as Fna by n, where Fne is the number of times event E occurs among these small n cases. In most cases, small n will be a very large number, usually few millions or few crores. Hence, the observed value of the rate may be taken to be a very good estimate of the probability that a person exposed to the risks of occurrence of capital E will actually have E during the given period. However, this interpretation cannot be given for such cases. Ratio of vital events ratio of the vital event here, the purpose is to compare the importance of one vital event E1 to that of other E2. The definition of the ratio is given by number of cases in which the vital event E1 occurs divided by number of cases in which the vital event E2 occurs into capital K, where I already mentioned that we generally take K equal to 10 to the power 3 or 10 to the power 5, since like rate, ratio is also expressed per thousand or per lakh of a population. Alternatively, if capital N, if capital N if capital N1 represents the number of occurrences of an event E1, which may or may not be may not may not be included may not include and another vital event E2, which occurs into in the population at the same time, into in a population at the same time. The quotient N1 by N2 is describes as a vital statistics ratio. Using the radix k, the ratio is expressed as N1 by N2 into k. The relative number of males and females in a population is measured by sex ratio, which is defined as sex ratio N1 by N2 into 1000, where N1 N2 are the numbers of females and males in a population at time t. Now, the probability interpretation of ratio Apart from the constant, the ratio can be written as Fn E1 by Fn E2, and we can write it as so ratio of E1 ratio of E2. Supposing the total number of exposures to the risk of occurrence of vital events in each cases is small. Because of the probability interpretation for rate, it can be said that in most cases this ratio may be taken as very good estimate of the ratio of probability E1, because Fn E1 by n is a estimate of this, and again this is a estimate of probability E2. So this ratio is nothing but a estimate of the ratio of probability E1 and probability E2. Now the we discuss mortality rates. Today I discuss only crude death rate. In my next class we discuss specific death rate. So the crude death rate the simplest type of this is a simplest type of rate used in measurement of mortality is the, and we denote this by, in short we denote this by CDR. C for crude, D for death, and R for rate. So CDR is defined as D by P into 1000, where this D denotes the number of deaths from all causes which occurred in the population of a given region during the given period, and capital P denotes total population size of the given region during the given period. So CDR gives the death rate for 1000 population. Now we discuss advantages and or merits. It is the most widely used of vital statistics rate. It is easy to compute and understand, as well as it requires only the total number of death and total population size. It is simple to interpret because it gives number of death that occur on the average per 1000 people in the given community. It has a probability interpretation. If all the people of the region are taken to be equally exposed to the risks of the death from same cause or other during the interval, then CDR can be regarded as the probability rate of death. This is the classical definition of probability. And demerits or drawback or disadvantage is are mortality depends very much on the compositions of the population by age, sex, occupation, place of dwelling, race, etc. But CDR does not consider any of these facts. Because of the first defect, CDR is unsuitable as an index of relative mortality. CDR is unsuitable as an index of relative mortality in different places with different age and sex distributions. For example, the region with high proportion of the old population will exhibit a relatively high CDR since aged people do contribute many deaths. The effect of death rate is to increase the numerator without proportionately reducing the denominator. This means population is abnormal by venture of shortage of young people. So, under the most circumstances, the CDR may well be used for comparing the mortality situations of the same place at different times, provided the periods compared are not too far apart, because in a stable large community the age sex compositions of population changes very shortly. So I want to stop today, and in my next class I will discuss specific death rate, and under this specific death rate I will discuss age specific death rate, sex specific death rate for age and sex, advantage disadvantage, then discuss standardized death rate. I will discuss standardized death rate. So I request you, please stay with us till then. Thank you.